For over 100 years, wood finishers have been using the only tool available to them for spraying a finish on wood. That technology has been conventional air spray. This technology has given them a very good finish, but has cost them dearly in transfer efficiency. Transfer efficiency, or TE as we call it, is a comparison of the amount of material coming out of the spray gun compared to what ends up on the part, expressed in a percentage. A typical air spray gun is 25% transfer efficient. That means 75% goes to waste, and this has been very costly to the industry. KREMLIN, a French company, invented AirMix and brought this new technology to the U.S. in 1980. AirMix gives the finisher the ability to put more material on the part and not into wasteful overspray. TEs of 70 to 80% are not uncommon. Here at Baker Road Furniture Company, they realize the benefits of AirMix. Today we want to show AirMix to you and explain exactly how to use it to your best advantage. Improper usage or bad spray technique will reduce transfer efficiency and create waste and overspray. Let's take a look at AirMix in action.
AirMix has been in use at Baker Road for several years now, and the benefits have been outstanding. The shop is cleaner, the work environment is better, and it has saved Baker Road a lot of money by giving them a very high transfer efficiency. This reduces material costs, but also reduces booth filter consumption, booth cleanup time, and even keeps compressed air costs down to a minimum. Here they are applying a wiping stain to the cabinets. Controlling the amount of stain is critical at this point. Too little and the surface is dry and the stain does not penetrate. Too much and your costs go way up in additional stain consumption, labor, and wiping rags. A sanding sealer is then applied and allowed to dry. It is then scuff sanded before the top coat is applied. AirMix has given Baker Road the superior finish they require and their customers expect. Now that we've seen AirMix in action, let's go back to the Excel lab so we can review the proper setup, maintenance, and operation of an AirMix system.
AirMix is a combination of two spray technologies, airless and air spray. KREMLIN took the low forward velocity of airless and lowered the fluid pressure to approximately 300 to 600 pounds. In doing this, we created objectionable tails in the spray pattern. But by adding a small amount of atomization air, we eliminated the tails and found we had a very smooth pattern. The specially designed air cap allows us to do this at a very low pressure, thereby giving us the lowest amount of overspray possible.
Here is a test of a typical air spray gun spraying into a cabinet. Look at the overspray being generated into the atmosphere. Now look at the savings afforded by AirMix as we spray into the same cabinet. Now that we have shown you the advantages of AirMix, let's take a look at how a system is installed and started up. This is how you will receive a 1014 system from KREMLIN. Remove it from the box and mount it to the right side wall of the spray booth. Today we are mounting it to a floor stand in our lab using the U-bolts provided. Make sure that the pump is properly grounded using the ground wire provided. Add the proper lubricant to the solvent cup before starting the pump. A clean, dry air line is to be provided to feed the pump and gun. I would recommend a 3/8 inch ID hose to make sure there is enough volume. Do not use quick detachables as they are very restrictive and we need a lot of volume so we can keep the pressure to the minimum. Take the hoses and mount them to the MVX spray gun. The air hose is 1/4 NPS thread and the fluid hose is number 5 JIC. This means you cannot cross the hoses and you will not need any thread sealant on this type of connection. Using electrical tape, tape the hoses together. Blow air into the hose sleeve and then insert the hoses into the sleeve. This will protect the hoses and keep them clean. Use the tie wraps at each end of the hose sleeve to attach the sleeve. Use a razor knife to cut the tie wrap so a sharp stub does not protrude. Now install the hoses to the pump. Make sure they are tightened properly. Install the siphon hose assembly and be sure to tighten it. Now we are ready to start up the system, but first we must flush it out with a clean, compatible solvent. Place the siphon rod into the container of solvent and point the gun into a grounded waste container. Turn on the air inlet valve and slowly turn up the red knob on the pump. The pump should start to run, and after a few seconds should siphon the solvent into the system and dispense into the container. Once you have filled the system with some solvent, remove the siphon rod from the solvent bucket and hold in mid-air while you continue to dispense into a waste container. Air will be sucked into the system and the solvent will be removed. As air starts to come out of the gun, insert the siphon rod into the material bucket and continue to dispense. When you start to see material come out of the gun, dispense until it is a solid stream and then shut off the gun. Now it is time to install the air cap and the tip. Always make sure before you do this that the tip gasket is in place and in good condition. If this gasket is loose, it will leak fluid past it and send it into the air passages of the air cap and back up into the air passages of the spray gun. A little bit of Vaseline on the threads is always a good idea to make it easier to install and remove. Without atomizing air, we want to show you the tails. They are very obvious and objectionable. We will now increase the atomizing air to 5 psi and spray a pattern. You can see how they have reduced in size. Now we will raise the atomizing air until the tails are gone. In most cases, 10 to 15 psi should be sufficient. Once the tails are gone, do not go any higher in atomizing pressure. To go higher just creates more overspray, and this is what we are trying to avoid. When you are spraying large flat surfaces, you will want to use the wide fan, but you may want to go to the narrow fan to spray small narrow parts such as chair legs or face frames. In order to get the narrower fan, you must unscrew the top knob on the rear of the gun counterclockwise. This closes down the fan to a smaller pattern. Now let's take a look at the tip chart and explain how to select a proper tip. Let's go to tip number 9 in the first column. At 500 psi, it will deliver 10 ounces per minute. At 1000 psi, it delivers 15 ounces per minute. So you can see just by changing the fluid pressure, you can change the amount of material going onto the cabinet. We refer to this as fluid control, and this ability allows you to fine-tune the film thickness on the substrate. This column explains the opening of the tip in thousandths of an inch. It gives us a comparison to the other tips and helps us to realize why we need such a fine screen to filter the paint. The next column on the tip chart tells us about the gun filter. The gun filter is the final filter before the tip. This gives us the ability to spray and prevent tip plugging. We have 3 sizes of filters available. 140 mesh for the number 6 tip and smaller, 85 mesh for the number 9 tip, and the 60 mesh for the number 12 tip and larger. We have a 9-digit part number, but only the last 5 digits are inscribed on the tip and only 4 digits on the chart. This means you have to take the number 134-5XX-XX4 and replace the X's with the numbers found on the chart. A typical tip would be 134-509-094. The 40 degree refers to the spray angle of the tip, and by going to the box below that, we find that we have a 9-inch fan pattern at 10 inches from the part. Now I will turn the tip horizontal and we'll spray a pattern on the paper. Notice how even it is all the way across the pattern. A dog bone spray pattern would blow out the middle, while a teardrop would mean the tip is plugged and must be cleaned. By spraying onto a waste cardboard, it will show the drips all in a row and very even, showing a consistent distribution of paint across the pattern. If a tip is plugged or partially plugged with paint, the best way to clean it is to remove it and blow backwards with a blowgun. Hopefully the particle will dislodge and be blown out. The use of a tip cleaning needle is a help if a particle is stubborn and does not blow out easily. If a tip has been left with paint in it and it needs a good cleaning, it is time to soak it in a paint remover chemical such as spray gun cleaner or immerse it in an ultrasonic cleaner to remove the thick, hardened paint. This should only take a few minutes and offers the least chance of damaging the tip. Do not use sharp metal objects of any kind. Please use soft brushes only.
Using AirMix will give you a very high transfer rate, but this can all be lost if the sprayers are not trained properly and using the correct spray techniques.
A common mistake a lot of sprayers make is to arc the gun in front of the product. This causes the film thickness in the middle to be the correct thickness and both ends of the arc to be dry spray. There are several techniques that must be understood to spray properly. They are distance from the part with no arcing and always stay parallel to the part. Speed of the spray gun, not too slow and not too fast to adjust for desired film thickness. And triggering on just before the part and off just after the part to prevent overspray. In addition, there are some general rules to use. Always spray the difficult areas first. For example, always spray the edges first and then spray any recesses or difficult areas. Then spray the overall face. In an effort to help sprayers maintain the correct distance from the surface, Laser Touch has developed a laser pointer. So if you are at the correct distance, there will only be one red dot. If you are too close or too far, there will be two dots. The use of the laser pointer helps new sprayers maintain a constant distance from the part. This really forces the user to pay attention to this important detail. Helping to eliminate the arcing and swinging of the spray gun is absolutely critical. As the spray gun moves inward, the two red points appear. The same is true if you pull away. This teaches the student sprayer to keep the distance the same so that the film thickness is even all the way across. Overlapping strokes 50% will assure an even coating. As the sprayer moves the gun across the part, it is important that he turn the gun on just as he approaches the leading edge and off as he passes off the trailing edge. You can see just by not triggering properly, the amount of paint used is increased and therefore the cost of finishing the product will be greatly increased. The part of the product that you see is always the area to be sprayed last, so you know you cannot get any overspray on that side. Therefore, you should spray the edges from the back side first and then the rear of the part if so desired. Whenever you are spray painting, you must always paint the difficult areas first. This will ensure that you get the difficult areas and will also prevent you from applying too much material in any one area, thereby creating runs and sags. You should spray the edges first, then the recesses or hard-to-get areas, and then you can adjust how much material is required to finish the front.
The best way to apply a finish is to build the film as slowly as possible. This means you should apply a mist coat first and allow it to dry. So the next coat, which will be a heavier coat, will have less of a tendency to run or sag. We have given this a light coat, so let's go over it once again and give it the finish coat.
When teaching people to spray, they must learn to gauge speed and film thickness.